This is part 2 of the 5.7 video series. We're going to be discussing Descartes' Law of Signs, which says that the number of positive real zeros of the function is the number of sign changes for f of x, or less that by an even number. The number of negative real zeros of the function is the number of sign changes for f of negative x, or less that by an even number. Today in class we talked about finding the total possible rational roots, and we could get this huge long list. We found that not always are our roots going to be rational. Some are going to be irrational, some are going to be imaginary. What Descartes does is actually allows us to narrow down that list a little bit further and to say, I'm going to have this many positive, this many negative, and this many imaginary. So we're going to take this first function, f of x, and I want you to look at it, and I want you to realize that the first term in this is positive. And I'm looking for sign changes, so I'm going from a positive to a negative. That's my first sign change. A negative to a positive, that's my second sign change. Positive to a negative is a third sign change, and then there are no more sign changes to the end. Everything stays negative. So there are 3 sign changes. And what Descartes says is the number of positive real zeros of the function is the number of sign changes for f of x, which is what we are looking at, or less that by an even number. So I have 3 sign changes, and now I'm going to subtract by an even number. So I'm going to subtract 2, and I get 1. What this tells me is there are either 3 positive zeros or 1 positive zero in this case. So I just rewrote, just want to reiterate that I now know that I either have 3 or 1 positive zeros. I'm now going to look at that same function, but at f of negative x. And what that means is everywhere there's an x, I'm going to plug in a negative x. Minus 2, plug in negative x 5, plus 3, plug in negative x to the 4th, minus 10, plug in negative x cubed, minus 6, plug in negative x squared, minus 8, plug in negative x, minus 8. And I'm going to go ahead and put the negative x's to the 6th or to the 5th or to the 4th, whatever. So negative x to the 6th is actually going to end up to be positive x to the 6th. Because negative times negative times negative times negative times negative times negative is a positive. Then I'm going to do minus 2, and this is actually going to end up being, I'm going to change that for a minute. When I evaluate this, the x to the negative x to the 5th is actually going to be a negative x to the 5th. Multiplied by the negative 2, I'm going to end up with a positive 2x to the 5th. Okay? Over here, negative x to the 4th is going to be a positive x to the 4th, so this ends up as 3x to the 4th. This right here will be negative x cubed, so this will stay positive 10x cubed. Negative times negative is positive. Negative x squared is a positive x squared, times the negative 6 stays negative. Negative 8 times negative x is positive 8x, and the negative 8 is my constant. I'm now going to look at my sign changes. So I start off as a positive, and my first sign change is here. I go from a positive to a negative, go back to a positive, go back to a negative. So there are also 3 sign changes for f of negative x. I'm going to, sticking with Descartes, it says the number of negative real zeros of the function is the number of changes of sign for f of negative x, which is 3, or less that by an even number. So I'm going to subtract 2, which is my even number. That's how many possible negative zeros there are. Okay, now what I'm going to do is I'm going to make a table. Positive, negative, and imaginary. So think about all the different possibilities. I can have 3 positive and 3 negative, Well, since this is to the 6th, I should have 6 total. I'm going to put a final column on here because my total should always be the total, which would leave me 0 imaginaries. But if I have 3 positive and only 1 negative, then that would leave me 2 imaginaries for a total of 6. I could have 1 positive and 3 negative, which would leave me 2 imaginaries for a total of 6. And I could have 1 positive and 1 negative, so that would leave me 4 imaginaries, which would add up to 6. I want you to notice that my imaginaries are always an even number. This is because, remember, an imaginary also always has to come with a conjugate, so it has to have a plus and a minus. So this column should always be 0 or an even number.